If you don't have the gauge on the right-hand side, the one I have with the temperature probes, which are up on the upper right-hand side of that picture, if you don't have that, then you need a temperature probe to work on a refrigeration system. The one in the middle is probably about $15 at a supply house. The one on the left you can get as little as $8 on Amazon. And that one has actually two probes, one for the high side and one for the low side. You don't always need those. One is usually enough. It's just faster and quicker to use two at a time. But these are just what they look like, and this is something that's your second most important thing next to your gauges. So this is an outside condensing unit. You have the suction line, which is the larger line, and a liquid line, which is the smaller line. There's 4 points on this I want to make you aware of. The red arrows pointing towards the service valve for the liquid line, or the high side line. The blue line is pointing to the low side, or suction line, and then two yellow arrows where you would put either tape on or put a clamped on thermometers there to tell you what the temperature of the pipe is. There's two ways to figure out if the unit's charged properly and working properly. One is the old school way, which is called superheat. New word. You're going to have another new word on this slide. It's superheat. Superheat is a temperature difference between the refrigerant temperature and the actual temperature. And we don't use that a lot anymore, because to use that, you cannot use a TXV. And most units now have TXVs. So the superheat is something that most manufacturers don't recommend. And the problem is, it's better, I think, but to figure out if you could do it or not, you would have to go to the air handler, open the box, and see if it's got a metering device other than TXV. So if this unit's up in the attic, you're going to have to crawl through the attic. It's hot as heck up there, and you have to take the door off just to see you got a TXV, so you can't use it anyway. So I think the less accurate method is what's called subcooling. And that's the red line and the yellow line on the bottom. That's where you use the high pressure line. And manufacturers now pretty much figure you're going to use that exclusively. So most label plates on the unit will tell you your subcooling needs to be 10 degrees. And I'm going to explain what that is right now. So say you put your high pressure liquid line hose on that service valve, and it shows the little gauge up on the top left-hand side of the slide shows that it's at 325 psi. And if you could see that purple line or the pink line, I'm not sure exactly what color that is, but the pink or purple line, it's going right over 100 degrees on the 410A. So this unit is 410A, we know that. So what is subcooling? Well, what it's saying is that refrigerant, this 410A, at 325 degrees, the refrigerant will be, by a temperature pressure chart, at 100 degrees. But this refrigerant has just went through the outside condensing coil and condensed the refrigerant from a vapor to a liquid, and it's cooled it slightly. So we're going to try to figure out what that cooling is. So when you look at your thermometer that's on the lower, smaller line at that yellow arrow, it's going to say the temperature of the refrigerant is actually only 90 degrees. So there's a difference between actual, which is 90, and gauge pressure degrees. So there's the difference. There's a little difference for when it condenses, and when it cools it off to condense it, you're going to have a difference in temperatures. So if you take the 100 degrees that you're reading on your gauge in the top left-hand part of that screen, and your thermometer that's on the yellow line over there, there's a difference of 10 degrees. And that's what you call subcooling. So this unit has a 10-degree subcooling. Now, if it might be supposed to be 8, it might supposed to be 12. I don't know, depending on the unit. But that's how the definition of subcooling is the difference between a gauge pressure and a gauge temperature and an actual temperature. on the high side line. I know that's maybe a little confusing, but we're going to go over a lot more before you need to use it. Here's a video I found on YouTube, which is it's a pretty good video. It's basic refrigeration cycle with subcool and superheat, and he says it's the easiest. I don't know if it's the easiest, but I enjoyed watching it. So here you go.
So you have refrigeration cycle, all right, and we're looking at subcooling and the importance of superheat. All right, so we're just going to do a quick rundown on the refrigeration cycle, and then we're going to go ahead and get started. So what you have is you have a low pressure, low temperature vapor coming into the compressor, and then high pressure, high temperature vapor coming out at its hottest point. All right, then it enters into the condenser coil where it starts to reject heat until it becomes a saturated state where vapor and liquid both exist. After that, it then rejects more heat as a liquid. Okay, it's out of its saturated state, turns into a liquid, and then continues to drop in temperature until it comes out past the valve. That is called the subcooling there. All right, the temperature decrease in liquid form. All right, it continues to go through the refrigerant line until it goes through the filter dryer, which absorbs any moisture in the refrigeration system, and then it hits the metering device where there's a pressure drop. It drops from high pressure, high temperature liquid refrigerant to a low pressure, low temperature, 80% liquid, 20% flash gas, but mainly liquid. After that, in the evaporator coil, as it absorbs heat, it then turns into a saturated state in the middle of the evaporator coil. All right. After it turns into a complete vapor, right after the saturated state, after absorbing heat, right where it turns into a vapor to where it comes out of the evaporator coil at, that's called the superheat. It's the temperature increase in vapor. All right. It then continues to proceed over into the compressor as a low pressure, low temperature vapor, and the process starts all over. All right. So, why do we need subcooling? All right. The subcooling is needed, which is the temperature decrease in liquid form inside the condenser. All right. You need subcooling to make sure that when the liquid finally gets over to the metering device, it has complete liquid and there's no vapor present. If there is vapor present, it's not going to be very efficient. Okay, it needs to be a very, very high or very far spread apart pressure drop. All right, the molecules are all actually spread apart in the evaporator coil when you reduce the pressure, but when you have the high pressure, high temperature liquid refrigerant coming to the metering device, all the molecules are packed real tightly. Okay, so it helps reduce the pressure. All right, when after it goes through the thermostatic expansion valve, the molecules are all spread out. All right, and then the temperature becomes much lower. All right, a very easy way of remembering what superheat is it's the temperature increase in vapor form in the evaporator coil. All right, you can simplify it down to that. All right, because there's only one spot where there's vapor in the evaporator coil, and it's after the saturated state, and then you're taking your temp reading and your pressure reading potentially right after it gets out of the evaporator coil. You know, we usually don't have ports there right after the evaporator coil, so we're taking our reading as a total superheat out at the compressor. But basically, superheat is the temperature increase in vapor form in the evaporator coil. Okay? The condenser, that's where we have subcooling taking place at. And subcooling is the temp decrease in liquid form in the condenser. Okay? To where it comes out past the service valve. That is subcooling. So there's only one spot where there's liquid in the condenser coil, and it's after the saturated state. All right, where it comes out at, we always take a temp reading right next to the service valve because that's where we can get an accurate pressure reading at. So that is a subcooling. Subcooling is the temperature decrease in liquid form in the condenser coil. All right, we measure it at the service valve. So that's I just wanted to kind of simplify that for your thought process and trying to memorize what is superheat and what is subcooling.
Well, that seemed pretty straightforward. Thank you for watching, and I'll see you soon.